Okay, hello class. Right now we are going to be doing a second form of a linear equation. We have done slope-intercept. Now we're going to move on to point-slope form. So point-slope form, y minus y1 is equal to m times x minus x1. Note that m is the slope. x1, y1 is a known point on the line. So by known, I mean that we know this point. It is something like, oh, let's say it's 2, 3, something to that effect. So this is not a variable x1. X1, y1 is not a variable. The variables here are, I'll put this in red so we can see for clarity. This is the independent variable. This is the dependent variable still. So it's not that these are known points here. These are still variables, unknowns. We keep them as just x and y in the equation. X1, y1 is a known point. Okay, so, and normally I don't do this, but I just want to run through this really quickly, just because it's easy enough to do. This formula did not just materialize out of nowhere and show up on your video. It's very easy to see how we develop this, and here's how. We know the formula for slope, right? It's m is equal to y minus y1 over x minus x1. And for those of you who are observant, you've noticed that I didn't write the sub 2 for this x and y. So let's just pretend that that's not there for right now. This is sort of a different form of this where x1, y1, x2, y2, those are also known points on the line, like this 2, 3. These points x and y here are not known values. They can take on any values of x and y. So they are the variables, the independent variable and the dependent variable. So I'm still safe to write that. I can still write these as the any points of x and y, and then x1, y1 as a known point of x and y. So what happens here when I multiply both sides of the equation by x times x minus x1, x times or sorry, times x minus x1. This denominator here cancels with x minus x1 because this just becomes x minus x1 over x minus x1 as a fraction. What's the common factor between each? It is 1, so I divide both by x minus x1. And what am I left with? Essentially, it cancels x minus x1 from both sides of the equation. So how can I write this? I'm just going to flip these sides, but then I can rewrite this formula to be y minus y1 is equal to m times x minus x1, which if you were paying attention, is just simply the formula that was given at the beginning of the video. So this is how it's derived. It comes from the formula for slope. Okay, so let's move on to the problems. Here we are writing an equation of a line with a slope of 1/2 that passes through the point 2,5. So what am I literally doing? I'm literally substituting for y1, m, and x1, right, in this formula. And now my pen has magically decided not to work. Let's just, oh, here we go. We're back in business. Okay. And then this is x1. Okay. So I've given you this formula here. This should be relatively easy. All I'm doing is just substituting these values in. Y minus, what's my y1 value? This is the point x1, y1, right? x1, let me put the comma in between, x1, y1, and here we have the slope. So I'm just literally substituting these values. What is y1? 5 is equal to, what's my m? 1/2. And then I'm keeping x, and what's my x1? 2. Perfect. That's my final answer. Let's look at another one. Write the other equation of the line with a slope of 3 that passes through the point 2, -3. Here we have something a little bit more difficult. Note this is still just x1, y1, right? And this is still m. But note what happens here. This is a negative value of y. So when I substitute, what am I really doing? I need to fill in or substitute for -3 here. It's still y minus a y1, so it's y minus a -3. That's what I'm substituting for. And then 3 times x minus 2, because I just filled in for x2. So obviously, the complicated part here is filling in for -3. What does this simplify to? Minus a negative number simplifies to an addition statement. So my final answer is y plus 4 is equal to 3 times x minus 2. Now, if you left it like this on a quiz or test, -1. No, bad. In fact, let me say this. Let's even do this in the red pen. Yeah, -1. Yes. And then I would do this here. Oh, check. Love it. Correct answer. So make sure that you do minus a negative number because you're substituting in for -3 for y1, and then that converts to addition. This statement down here is fully simplified. Okay, so I want you, let's switch back to black here, and I want you to try one. Okay, next type of problem. Given an equation of a line, find the point and the slope. So we're doing the same thing except opposite. Here we're giving you the equation in point slope form, right? And I want you to give me what the point x1, y1 is and the slope. So because these are both subtraction statements, this looks visually subtraction, 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 exactly like it should to identify the point. So this one, once again, this is an easy one to start out with. I'm just taking my known x value, 2, which I got from over here, my known y value, 4, which I got from over here, my slope, just simply the coefficient to this expression in parentheses, is 3. Easy enough, right? Okay, becomes a little bit more challenging. We're dealing with negatives here as well too. Note that in my original equation for point slope form, I have this negative here, y minus a -1. That doesn't visually look like the left-hand side. This is an addition statement. So to do this, what I'm going to do is rewrite this as minus a negative. Therefore, I can then easily identify what x1 and y1 are. Now, will I expect you to write this come quiz or test, take out points if you don't? No. If you can mentally do this in your head and know for sure that the y1 value is -4 when looking at this as y plus 4 on the left-hand side, sure, I say go ahead and do that. But maybe to begin, start by rewriting this. Put this in the form of these two subtraction statements, y minus and x minus over here in parentheses. This way you know for sure that you're taking care to say yes. This is actually 1 -4, right? From this one, that -4, and my slope is 3/4, the fraction. Okay, once again, your turn. Try one, please. Thank you. Okay, next and last type of problem. Converting from point slope form to slope intercept form. Here is where we have our friend, the distributive property. What? You thought it would go away? It will not go away. We are using the distributive property forever in your algebra life. Okay, so by distributive property, what do I mean? This is in point slope form. I want to convert it to slope intercept form, which just to refresh is y equals mx plus b. So what am I doing? You can call this, if you want, solving for y. So when I say solve for y, what does that really mean? You can also call this isolating for y, right? Isolate for y. Wow, this pen is really bad handwriting. Okay, at any rate, hopefully everybody can read that. Solving for y, isolating for y. What do I mean when I want to do that? Okay, here's what I mean. I want to basically make it, and here's how you should think about it. Y is equal to something on the right-hand side. I need to fill out what's here in red, what I'm basically putting in this red box here. I need to put something inside of this box. I am just literally reorganizing the left-hand side of the equation, moving everything over until I get what I need. I need to simplify the right-hand side, but once I do and combine like terms, I'll have y equals mx plus b, which I require. So let's do this one here. What is my first step? I am using the distributive property on the right-hand side here, 2 times, because remember what this means. This 2 is outside the parentheses. This is actually 2 times x and 2 times 5. So that's what the distributive property states. I will write it here if you do not remember. A times b plus c is equal to ab plus ac, right? A times b, a times c. You sum them together. So this becomes 2 times x is 2x. 2 times 5 is 10. Right. What's my next step? Isolate for y. Add 3 to both sides. Add 3 to both sides. I added 3 because that undoes this subtraction. And I get y is equal to 2x plus 13. Is this in the form of y equals mx plus b? Yes, it is. here we have our answer in slope-intercept form. So I've converted from up here, right? I've converted from this, well, that is the most horrible circling job ever. I've converted from point slope form up here, and now I have point slope intercept form. Okay, circled a little bit better. So I've gone from point slope to slope intercept. Okay, I'll do one more. This one is a little bit trickier because of the fractions. Note that you will see these with fractions. I'm not going to just sort of never make you do problems with fractions. That would be extremely cruel and unusual. Okay, so I'm keeping the left-hand side. The first step is to distribute the right-hand side. What's 3 times x? What's 3 is 3x? What is 3 times 1/4? 3 times 1 over 4. Now remember how you should think about this. This is really, and this is something a lot of students can do in their head, but I just want to be completely clear. Multiplying fractions. That's 3 times 1, okay, and 1 times 4. This is a process called multiplying through. All you're doing is multiplying numerators, multiplying denominators. What's 3 times 1? That's simply 3. What's 1 times 4 is 4. Perfect. Okay, so plus 3/4. Now, what am I really doing here? I'm adding 7/8 to both sides, plus 7 over 8 on this side, plus 7 over 8 on this side. Okay, left-hand side, easy enough. That is super easy. Clearly, these cancel. This becomes, sorry, cancel. Ugh, man. Man, do I hate when students say that. Why do I say that? They add to 0. Things not canceled. Adds to 0. On this side here, and I'll rewrite this, this is you keep the 3x plus 3 over 4, but you're adding 7/8. So what you really want to do is in yellow, let's see if I can actively use this again. Yes, no, yes, no. Oh, that was still bad. I am adding 3/4 and 7/8, right? That is my job. That's my goal. That's what I want to do. So I'm going to do that work off to the side here, just so it's abundantly clear. Okay, 3/4 and 7/8. What is my first step? My first step is to find common denominators for both fractions. What's the least common denominator being 4 and 8? It is 8. So what fraction do I have to multiply 3/4 by to get the fraction 3 over 4 to being over 8? 2 over 2. So I convert this to being 6 over 8 plus 7 over 8. Now, because both of these are over 8, that's why I wanted to find common denominators, at least common denominator. I wanted to find a suitable number to multiply 3 over 4 by so I can get a fraction that is over 8, so then I can thereby add these. I can't add these together until they're both over 8. So what is that fraction? 13 over 8. No, fractions will not disappear. They are your friend. So because that's 13 over 8, I will rewrite this in its final form. Y is equal to 3x plus 13 over 8. Final answer. Okay, the your turn doesn't contain fractions, but no one's to say that on some assessment involving this work, you won't have to do some sort of adding fractions. It will not go away. So try the your turn problem, convert this from point slope form to slope intercept form, and I will see you in class on Tuesday.